And now we're going to continue on the remaining part of this lecture. And at the same time, this is the last topic that will be included in the final exam, which is the Health Layer 7 standard, HL7. Okay. We basically learned in the networking part that we have 7 layers. Basically, each network has 7 layers. Some of these layers are physical, like the connectivity layer here, the part that is related to the modem and how the ones and zeros are transferred between different systems and things of that sort. And all the other layers are kind of software or protocol layers. The very last one of them is the application layer. Basically, this is like the browser you have, for example. If you're using a browser, then you are on the application layer, okay? HL7 actually is an application layer part of the networking protocol, basically. So basically here, as you see here, HL7 is like HTTP, for example, like Telnet, like things of that sort, like FTP also you can actually consider it one of these things. So basically, HL7 is an application layer protocol that would be actually used to communicate between different systems and basically provide connectivity between different systems to exchange medical information. So basically, this standard was born out of need for connectivity and integration to enable exchange of textual healthcare information to the benefit of patients. Okay, so this is very important. Whenever you need to, for example, communicate a report, for example, this can be used. Okay, and basically not just that, you can actually communicate a lot of information between different systems, as we're going to see now. Okay, so the original standard of HL7 standard was actually developed by researchers. Okay. And it was actually basically used in universities and things of that sort. And basically a commercial one was developed out of a predecessor research standard. Okay, so basically this was as early as 1970s. Okay, basically it's very different from DICOM because basically DICOM is related to images, and images at that very early stage actually was not that were not that common basically. In the 1970s, most of the information was related to basically some parts of the EHR, like lab results, like, for example, sort of list of medications, basically a report from a doctor, things of that sort. And basically, you're talking about a very early standard that became available in the 1970s, basically. And it was first used more widely in university or development settings from 1981. So basically it was there from the 1970s, but it was much more commonly used basically in the 1980s, starting from 1981. Okay. The name, as you see here, Health Layer or Health Level 7, okay, it's named after its position in the 7-layer OSI model. Basically, this is one of the models that we talked about, basically the OSI model. Basically, as you see here, it's basically the HL7 is here. So basically, it's called Health Layer 7 because it's an application layer that sits in the 7th layer of the networking protocol. Okay. Unlike the DICOM standard, HL7 is a closed commercialized standard maintained by Health Level 7 International Organization. So basically, this organization here is the organization in control of this particular standard. Basically, it's like one of the standards that we see. Basically, if you look at the ISO standards, for example, or the AMI standards, for example, all these are organizations that develop the standards and maintain them. And then if you want to access the standard, you have to buy it. Okay, you cannot access it for free. DICOM standard is very different because it's free, basically. It's a community, basically as an open source standard that was developed by the whole community. So basically it's available for everyone to download and use, okay? Until 2013, basically, it was completely unavailable for quick review even, okay? You cannot even, look at certain parts of it, like a quick review just to know exactly what it contains, okay? Without paid membership of the organization. So basically, you have to be a member of this organization in order for you to be able to access that standard. due to the pressure from the community and from the industry and from the researchers, basically, it became available for download, but only for personal use after that. Okay, but so basically, if you want to get a copy of a certain part of the HL7 standard, you can actually get it, but you're not allowed to develop a product using it. Okay, so basically, if you want to use it for personal use, if you want to do some research, things of that sort, you can actually use it, but you cannot distribute it. You cannot basically, if, for example, if you're going to in a class like this, if I wanted to basically refer you to a part of the HL7 standard, I have to ask you to download it yourself. I cannot distribute it myself to you, okay? Because it's basically, the license is only for personal use. So basically, I download it for myself. I cannot distribute it to anybody else. And therefore, the standard remains guarded in contrast to the DICOM standard. Guarded means that if you infringe on the copyright of this standard, you will be basically, this organization will probably sue you for it, okay? So basically, closely guarded means that it's like a copyrighted material, and basically, whenever somebody uses that copyrighted material in a different way from what is allowed, basically he can be prosecuted for it. So it's a very different way of thinking, actually, from the DICOM standard. So in general, if you talk about the function of HL7, HL7 are composed of messages that look like this, basically. See the messages? So basically, as you can directly, basically, your first impression would be that basically the information is not very clear. Okay, if you try to read it, if you try to, as a human, basically, it's not human readable. It's not intended for humans to read, basically. They are intended, all these messages are intended for machines to read. Okay, so they are text strings. So as you see here, all the information is in text. So you can display them, okay? But they are formatted in very specific, defined, and repeatable ways. So basically, you have to basically write the message in a very well-defined manner in order for it to be valid. Okay, each message has every possible field either filled or left empty, and separated by specific characters called delimiters. For example, here the delimiter used here is this character here. Okay, so basically you can see it here separating different things. You can know that they are different things because they look different. You don't really understand what they mean, but they are different. They look different. Okay, this is not the only characters that can be used for that. You can use actually other characters to do that as well. Okay, so basically you have for each one of these messages. So this is the message. This is the message. The message ID, for example, like the tags that we saw in the DICOM. So you have certain fields for each one. So the standard defines exactly what each one of these messages should have as fields, and basically it tells you exactly what to put in each field. Okay, and you separate the fields by the delimiters. These special characters that would be used as separators between the different fields. Okay, so all the possible data types for particular fields are defined by the standard. So you don't have here something called private fields, for example. You don't have that. Okay, everything has to be standardized. For the version 2 of HL7, the messages are intended for machine use, okay, and interpretation. So basically, it's not meant for you, for example, to read it and interpret it and know exactly what it means. If you want to do that, it's going to be really hard. It's what I mean by it's machine use for machine use and interpretation rather than human manipulation. It means that if a human wants to get the information, he probably can get it, but actually it will take him much longer than a machine to do that. Okay, so you're sending certain information, like for example, when you're transmitting data over a network, for example, we saw that we send a lot of things. We're not just sending the material that we want to send. If you're sending an email, it's not going to be just the text that you wrote. You have a lot of things that are sent as well. So basically, these things are meant for the machines to communicate with each other. Make sure that the message is correct. Make sure that everything that you send is interpreted correctly. And basically, this helps the communication to be done in a reliable way. So basically, the HL7 is meant for machines to communicate with each other. Okay. Whenever the message reaches a particular machine, it can be interpreted and basically displayed in a particular way, or it can be used to do a certain function or communicate certain information or whatever. So basically, you have what's called message segments. Okay, let's talk about certain examples of messages. Okay, the first one is message header information. So basically, first of all, you have message delimiters, and basically you can use characters that are these characters are the characters that can be used as delimiters. You can use this one here, this one here, this one here, this one here, this one here. This means that these characters cannot be used elsewhere in the HL7 message. So basically, if you have, for example, a message that has A and E, for example, okay, you cannot do that. You cannot have the AND here. It's not possible because basically it's one of the delimiters, and basically it would be interpreted as a separation between this field and this field, and this is not what you mean here. Okay, so basically whenever you need to use one of these characters, you have to do something different. You have to use a certain set of basic, or replace this with a different character that would be interpreted as AND on the other end of the message. Okay, so whenever it's received by the recipient, he would actually replace the characters that you replace the AND with an AND, but you cannot use an AND. Okay, so basically the first part of the message will be the message header, the actual name of or basically the acronym for the message, and then you have the set of delimiters. And basically, the set of delimiters means that you have basically you can use these as delimiters, basically. So basically, whenever you find them anywhere here, you consider them as delimiters. Okay, this is very important. So basically, if you look at this, for example, here, this is a delimiter here. Okay, it separates these two. Okay. You have to have origin and destination. So basically, here you have origin and you have destination. Basically, this can be basically a certain part of the machine. Basically, if you communicate it between different, like a modality and packs, for example, basically it might be basically a certain unique name for a particular modality, and this is basically a unique name for a server, for example. Okay, but you have to have the origin and destination here. So that basically when you send this message actually gets on the network, and it has to, it has to reach a certain destination. And whenever it is received by the destination, it has to know exactly where where it came from. Then you might have date and time. You might have the message type. Basically, for example, if you have here the message here, the message header information, basically here you can have ADT, for example, admission, discharge, and transfer, for example. Okay, so whenever you're sending that information from HIS to the packs, for example, you use a HL7 message, and basically the topic of the message or the message type would be ADT. Okay. Sometimes you have a trigger event. The trigger event is the event that triggered this particular message. Okay. And each one of these, if you have A01, for example, it has some interpretation. It means a certain thing that is different from A02, for example. Okay. So basically, you want to know exactly which one of these, for example, admission or discharge or transfer. Okay. So basically, you have to have that information in one of these. Basically, you have to define it in the trigger event. Sometimes you have a certain unique ID, control ID for the message. Sometimes you have to have something called processing ID. Sometimes you have to have a version ID. All these things are basically things that would allow you to uniquely identify this message, because you receive so many such images, so many such messages on a particular server. So basically, you have to know exactly what this message, a unique ID for each message, so that you can differentiate it from the other message that you receive. By the way, you're not expected to understand all of these. I just wanted you to get a feel of how this communication protocol or how this standard works. Okay, you're not going to be asked to understand. I would not ask you, for example, to get this message and basically tell me exactly what it means. Okay, there might be a simple example of that I'm going to show you at the end, but actually it's basically just for you to understand or get a feel of how such messages are composed and what kind of information you should expect there. Some other messages like event information, EVN, for example, it has when the event was recorded, when the event occurred. Sometimes these are different, okay? Who was responsible for it, okay? You're not talking about a person. Sometimes it's a person, sometimes it's like a machine, for example. Like, for example, if you have a certain update to the patient record, for example, sometimes you have to make that update through, it can be done actually through a lab information system, for example. Okay, so basically that the lab results were added to the patient file, for example. So basically this would be the lab information system, for example. Sometimes it's a person that does that. So basically you have to specify who is responsible. You have to sometimes put the event name itself. Okay, sometimes the events have unique names, so basically you might actually include them there. You have something called PID, patient identification information, which actually includes some identifiers like the if you have a serial number for the patient, for example. If you have name and addresses, sometimes you have the names that are put this way here. So basically, sometimes it's clear. You can actually, sometimes you can actually interpret this, but it's not really. It doesn't happen all the way. You cannot necessarily deduce all the information by reading the. It's sometimes difficult actually to get the information out of the message itself. You might include also the date and time of birth, the gender, the account numbers. If you have a certain insurance company, for example, for this patient, you might actually add that in the message. So basically, this is very important also. Sometimes you have something called PV1, which means patient visit information. It has basically a class that identifies whether it's an inpatient or outpatient. Inpatient is the patient that resides in the hospital, he's actually staying in one of the hospital rooms. Or outpatient, like when you go to the medical center, you just get a consultation from a doctor. So basically you're outpatient, you just go to visit the doctor and go back home. So basically you identify which one of these. You have to identify the doctor, whether it's an attending doctor, basically the one that you actually basically went and saw. Sometimes you have a consultant as well. Sometimes you have a referring doctor. Sometimes you refer to that doctor by another doctor. So basically you might actually have the information of that doctor there. If the patient is an inpatient, basically you might have an admitting doctor. So basically the patient may have come earlier and basically was admitted by one doctor, and then while staying at the hospital he actually saw another doctor, an attending doctor basically, and there might be a consultant that would actually review the results or the information from the attending doctor and basically might write some modifications or confirmations about what was basically given to the patient. The referring doctor might be the one who actually referred the patient to that hospital or that doctor. You might also have the admission or discharge date and time. You might have them included also in that particular field there. Sometimes you have something called OPX, observation information, okay? It depends on the kind of information. Basically, you might have the data type. You define the data type of the observation and basically the attribute basically of the attribute that you are measuring. For example, if you look at here, for example, you have body height, for example, okay? Height might be in meters, for example, okay? So basically you define here the data type as numerical, for example, okay? And basically it's a decimal number, okay? And it has units, value and units, like meters, for example, or if you're in the UK or US, might have feet, okay? And you might have observation status such as preliminary or final. This actually can be for such things as height and weight, which do not change, and might be also for something like temperature, for example, which changes often. So basically, it depends on the kind of information that you're measuring. You can actually specify them there. Okay. Another message actually is related to the allergy information. Allergy information is very important, basically. So basically, you have a field that would describe the severity of that allergy and basically the type of allergy, or basically which substance would actually trigger that allergy, for example. Okay. Basically, as we see, other message type, basically, we can actually look at particular examples here. Basically, if you're talking about the type of message has to be defined within each header. So basically, you have so many different types. As we saw some examples of these, but there are so many of them. And basically, the messaging operates on read-back confirmation basis, meaning that basically, you have a message called ADT. The recipient would basically send the same message with a prefix of ACK, acknowledge. Okay, it's readback. Readback means that as if you're basically you're dictating. If you have basically you're mentioning your phone number to an operator, for example, over the phone. And after you finish your phone number, he would read it back to you so that you confirm that this is okay. Okay, so basically here the same message is sent with the message type, and then you get an acknowledge with the same information so that you can confirm that this is actually what was sent. If it's different, then you send it again. Okay, so basically the prefix of ADT, admission, discharge, or transfer, or acknowledge is appended depending on whether it is the original instruction from the requesting system or a confirmation. So basically the original message or the confirmation response from the receiving system. Okay, so basically when you send a message from MPI, basic multiplanar image construction, for example, to RIS, for example, if you have a system, a computer system that does multiplanar image construction to the Radiological Information System with the message type ADT A04. Okay, A04 is the type, basically is the message. Basically, you have to have each one of these. It has a certain value, for example. So if it's A04, it means that you're registering a patient right now. Okay. So basically, whenever the RIS completes the action, okay, requested, it replies with ACK A04 to confirm the action was done. Okay, so basically it goes like this. So basically, you confirm that each message that you send is actually correctly received by the other party, so that you basically you forget about it after that. Okay. So this is extremely important because you don't want to send a message and assume that it was received, and then it ends up basically being lost in the way, and basically the whatever you requested or whatever you assumed reached the information you assumed that reached the destination wasn't there. Okay, so basically you have for the ADT, for example, you have different values here for the different action that you would have with this particular message type. Basically, for example, A01 means admission of a patient or a visit notification. 02 means transfer a patient. 03 discharge. A04 register, pre-admit. So basically, you have different messaging, and you have also very similar messages that actually cancel the other ones. Okay. So basically, if you have a message that was sent earlier with patient transfer, you can actually cancel it if you add 1 here instead of 0. Okay. Same message, if you add 1, then it means that you're canceling that information. Okay. So basically, this is just a flavor of how this standard works. And it's very important for you to realize that it's extremely important to have such a standard, because all the information sent using this standard is very much basically understood by everybody, because the standard is very strict. If you send a particular message in a particular way, then it would be actually interpreted the same way by any other system. And this is basically the basis of interoperability that we talked about. This is extremely important. So whenever you want to have interoperability, you have to make sure that the communication between all the individual medical informatics systems on your hospital basically use HL7 messaging. And whenever you do that, basically they will easily interpret or easily communicate with each other without any problems. Okay? So all the things that we talked about are in chapters 8 and 9 of this textbook. You have this textbook if you want to read some more information. And basically, this will be the last part that will be included in the final exam. Okay? We have only one lecture left about artificial intelligence in medicine. And I expect, inshallah, I expect that we probably finish it next time, inshallah. So basically, next week, if you want to have a review of certain parts of the course, it's fine. You just let me know exactly which parts you want to review again. If you want to have them off, it's fine. Some of you actually didn't submit all the projects. You have to submit them by the end of next week, so that you basically get the the credit for them. You don't want to miss on the project because they have a lot of marks. So basically, it's very important to have that. So if you have any question, please go ahead and ask now. I actually wanted to discuss with you about the exam, the final exam, but let me just wait for your questions first, and then we'll just take a few minutes to talk about the exam, the final exam. Any questions?
دكتور بالنسبة
Yes, go ahead.
صور الدايكون مثلا إذا كان التصوير عشان مثلا معرفة ورم سرطاني أو غيره، هل يكون فيه بيانات الورم في نفس الصورة؟
It depends. Basically, sometimes you have some information, but actually, usually no, because basically the images, the DICOM images originate from the modality, okay? They go later to the doctor to make the diagnosis, okay? So usually you don't have that information within the DICOM file. Sometimes if you're preparing a teaching file where you have several images with their interpretations, you might actually use the private tags that are available in the DICOM file to basically add that information so that a particular system for teaching, okay, that you use might be able to read it and allow the resident doctor to be able to basically view the interpretation after that. Okay, so this might be available in certain teaching files, but they are not generally available. If we're talking about the images that come from modalities, which is basically we're talking about the majority of images that are in DICOM format, basically you don't have that information. You just have the image information, the radiometric interpretation, basically how you're going to interpret the numbers and display the image correctly. You have the information about how the scan was done, but you don't have information about the diagnosis itself. Just be careful about that, because basically sometimes the diagnosis might be controversial. Sometimes if you give the same image to different doctors, basically it might give you different diagnoses. Okay, so you include only the information that are basically include facts. You don't include opinions. Okay, the diagnosis is somewhat opinion. Okay, sometimes you confirm the diagnosis after you get a lab result. For example, if a certain patient is basically diagnosed with cancer, for example, in order for him to confirm that this is cancer, it's not enough to have an image that says that. You have to actually get a sample and go to the lab and basically confirm that it's cancer. So basically, the answer to your question is generally no. The information about the diagnosis is not there. If you're talking about, for example, if you want to have a certain database to do research on, such images actually are available in databases, okay? And you can actually download datasets for, datasets for images with cancer that are confirmed that you have cancer. Basically, the people who prepare the database, did all their homework and did the lab results and everything, then confirmed that these images correspond to patients with certain types of cancer. So basically you can find that, okay? But if you're talking about the clinicians or the clinical use of images, the images that come directly from the modalities, you don't have any diagnostic information. Any other questions? Okay, so now I'm going to close the recording and then discuss with you a little bit more about the administrative part of the final exam, inshallah.